Hey guys, welcome to my first YouTube video on Fusion 360. I'm going to be making some videos about using Fusion 360 with your home CNC router. I know there's a lot of people out there doing it. I'm doing it. But Fusion 360 is probably the most powerful software you will ever get for free, but it's not really designed to run your home CNC router. It's designed, to mill parts for the machine shop. But it will do everything that you want to do with it, plus so much more, which is the reason why I use it. And so we're going to talk about some of the things that may not be obvious to the hobbyist or the home the home CNC router guy. But so let's just get into it. What we're talking about today is setting up the offsets for your V-carve bit. Fusion 360, and let's go up here to the CAM workspace. They have this engrave feature, which is some of y'all might be familiar with this type of cut. It's like the V-carve feature, where the tool path is calculated. It adjusts the depth so that the edge of your V-carve bit at the top surface of your stock material traces the contour of your design. It makes for, like, if you're doing, wood signs or some intricate design work, then it makes very sharp, very crisp edges that you can't get with with, say, an end mill. But a consequence of that is that the depth changes, where the V carve needs to cut out a wider area. It goes deeper into the material, and as it gets to narrower areas, it comes up vertically and is less deep in the material. So sometimes you'll need to know what the offset is for your V-carve bit. And what I mean by that is the point here, where the bit touches the top of the material. What's the distance between that and the center line of the bit, where the tip touches the bottom of the material? And there's a lot of reasons why you might need to know that. In fact, my next video is going to talk about that. This video is a setup for my next video, where you'll need to know what those offsets are. So be sure to hit the subscribe button and look out for my next video. But let's just get into it. Go back here to the design workspace. We're going to edit this sketch. So we don't really need this image here. It's just here to make it clear to you what it is that I'm doing. So the first thing we're going to do is use our line tool, and we're going to trace this contour. You see I have the tip of the bit right here down at the origin, and come back up, and we're going to close this profile. Now we'll need to add some constraints. You see that Fusion 360 has automatically put in a horizontal constraint on this top line, which is good. We need that. And we're going to put in a couple more lines. Let's do a vertical line and a horizontal line. All right. And then we're going to select both of those. Oops. And I'm selecting both lines by hitting Shift on my keyboard. And we'll come up here in the sketch palette, and we're going to make those construction lines. So now we'll need to add some constraints. We want to use a coincident restraint on this line to that origin point. And what that basically means is that it's constrained so that line will always go through that origin point. And we're going to do it again for the horizontal line. Okay. And now we need to put in some dimensions. You can use the shortcut key as D on your keyboard, and then we'll select all 3 points of our V-carve angle, drag up so that we get the angle dimension, and we're going to set that at 60, since this is a 60-degree V-bit that I have the image here, which we'll be able to change that as well later. And we need one more constraint on this horizontal line right here. we need to do a midpoint constraint that from this line to this line. And excuse me, what that does is just make sure that this line intersects the horizontal line directly at its midpoint. So now D on the keyboard again for dimension, and we're going to dimension the distance from this horizontal line, which represents the depth of our V-bit into the work material, down to the tip. Drag that over, and we can set that dimension. So let's say you're cutting 0.2 into the material, and now you want to know if your depth of cut is 0.2 of an inch, then what is the offset from the center line to this point at your stock work surface. So we can go up here to inspect, use the measure tool, I on your keyboard for a shortcut for that. Just measure from this line to that point, and Fusion 360 will give you 0.115 of an inch. That's your offset. So now one other thing that we can do so that you don't have to use your measure tool every time is because this sketch is fully defined, we can dimension this. D on the keyboard again will go from the center point to this point and draw it out. And now you see it's going to give you a warning that adding the dimension will over constrain the sketch, and by choosing OK you create a driven dimension. And what that means is now we can't click on this dimension to change it, but if we come over here and change this one, say we wanted to make our depth of cut 1/4 of an inch, then the driven dimension will automatically update. So now you have a handy sketch. We'll save this. We'll call it Vbit offset calculator. And so now it's there. Anytime that you need to make, to find out what the offset is, you come to this calculator. If you're using a different angle of a bit, say you're using a 50-degree bit, then it'll update for you automatically. You can change your depth of cut. And you can see that Fusion 360 does all the math for you. So, yeah, I mean that's it. Now, one other thing that we can do, this is with this sketch that we created here, you're using the depth of cut to find out what the offset is. Now, we might also want to know, if we know what the profile is, we want to find out what the depth of cut is. So what I'm going to do is create another sketch exactly the same way. I'll come up here and create a new construction line, and then we'll draw another profile. We need to make add in our constraints. This point to that point. It needs to be the midpoint. Let's go ahead and make this one a construction line. And then now we're going to set, because we don't have we can create a point here. Let's come up here and we'll create a sketch point, and we're going to place it right there. So now we can do a coincident constraint from this line to this point, and then from this line to this point, which that looks like it was already done. And let's do a equal constraint on the two side edges. It looks like it doesn't need all those constraints. So we'll go ahead and dimension it out. Um, for this one here, we want to know, well, we still need to know the angle. Make that one 60 as well. And we're going to say that the length on this line, this is what we already know. This is the value that we're going to enter. So we'll call that 0.2. And now what we want to, now this is still not fully constrained. It's on all. Let's just see. Let's see. I don't know why that's not turning back. But let's try it here. We're gonna change this dimension to. Oh, I know. It's because the whole thing can move. So we're gonna dimension from this point to this point, and now it's fully defined. So now we can do the same thing we did before with our dimension tool. Because it's a fully defined sketch, you can tell that because it turned black. If we dimension from this line to this line, oops, that was the wrong thing. From this line to this point, and now we should get the same thing we did before. Because it's over constrained, we're going to create a driven dimension. We say OK, and now when we change these two values, the bit angle or the width of the cut, then it'll update this driven dimension automatically. We'll try it. We'll say, and we're going through 1/4 of an inch, and that's going to make the depth 0.217. So there you have it. That's a way to find out what your offsets are on your Vbit. Just save this file in whenever you need that information, you just open it up. You get it. So keep an eye out for my next video. It'll be coming soon. We're going to talk about what you can do with this information when you're setting up your toolpaths for CAM, especially when you're using that engrave toolpath with Fusion 360. And we'll see you next time.